Okay, so next topic in statics is definition of a vector versus a scalar, and we need to deal with those. So start with our okay, it's a force that has just magnitude. It has no direction. It's just there. Okay, so it is 10 pounds. It just goes wherever. There's no angle to give us a direction or knowing a distance or any of that. Okay, but a vector has magnitude. So a force, whoops, I did that wrong up here. With magnitude only, yeah. With magnitude and direction. Oops, just put that down as a D. Okay, and that means we have £10 and we have an angle of 20 degrees, let's say. Okay, so we get the magnitude and we got the direction. Okay, so that's the difference between a scalar and a vector. That'll come into play later on when we do this. Alright, now there's a couple ways to find things that make this useful for us, and one of the things we're going to be looking at is finding the resultant of two, whoops, got hung up on my W there, I don't like that W. Two vectors, okay? So we can have, and I'm going to use a ruler for this to make life nice. Let's make it like so. We're going to go from that spot up. Alright. So that's going to be F1. Okay. And I'll keep it nice. We'll do, I'll do it square. Or not square, but we'll do it this way. And that's F2. Okay. And this one's at 0 degrees because this is going to be my x-axis, and there's my y. Oops, sorry, don't put the arrow on the axis. But we'll have some degrees in here, so we'll have some theta. Okay. Now, it doesn't matter. We can find the resultant for this if we know what this angle is through trigonometry, but the easiest way to do this up first is the parallelogram law, which means I'm going to take that and I'm going to measure the distance that I'm there. So we're going to do 1, 2, 3.3. So 33. So we're going to go here, and I'm going to go 10, 20, 30, 3. I'm going to draw this. Actually, should draw that in red so you can see the difference. I'm basically transposing the force F1 at the tip of F2. So we'll call this F1 prime. Okay, and then if I take 2 and I transpose it to here, we can get F2 prime, and our resultant comes out of this. And that is called R. And R will have a new angle. Let's call it alpha here based on that. So then we get a vector for R. Okay, so that's parallelogram. And it's the rule goes like this. Let's write the rule down. So okay, so parallelogram law is F1 plus F2 is equal to F2 plus F1. Basically, just what I did up here is I transposed the positions and I went tip to tail to do things. Okay, and oh, I know something I've forgotten here. Shame on me. R is equal to F1, and that's our vector symbols. F2, okay, and that gives us, that tells us we have a vector. All right, so this should be this and that and this and that. All right, so keep that in mind as we do this. All right, another way to do this whole thing would be to, instead of doing the parallelogram, do what I described earlier as tip to tail, but let me do it right here. And if we had this as the free body diagram, so that F1, if we took our angle and came off from the end of this one at that, slide over there, at that, and we went up to 33, then the resultant would be F2, F1, and our resultant looks like this. Okay, and then we actually get the nomenclature that is R equal to F2 plus F1, which we've already proved back up here that the parallelogram, if F2 plus F1 is equal to F1 plus F2, then the world's going to work. Okay, and this one is called the black to back to black. The triangle rule. Okay. All right, and generally that's what that is. We'll give you some homework assignments for that, and you'll be able to see what's going on with that. And I'll do some examples here of parallelogram and triangle rule for you in the next video.